Hi, welcome to this lecture. Here we will look into an entity and we will even try to write some queries. But before that, we need some background. So let's see what do I recommend. I recommend some readings because that will help you understand the lecture topic. So we will discuss data models. So if possible, you should look at data model from Wikipedia. We will look at the camel case, which is a convention that we use to name the table and the attributes of the table. And then if you have the textbook, then you may go over the chapter number 3 and the pages from 57 to 71. And then there is this reference which is about MS Access data types. So it will be great if you could have a look at the different data types which are available in MS Access, because that will help you in creating your database. Okay, so let's see what do we have here. The objective for this chapter or the lecture, we will try to understand the relational model. Okay, and then when we are looking at the relational model, we will try to have a look at how we can create a very simple relational database involving just one entity. So we are not making it too complicated. Let's make it very simple and try to understand how we will represent a single entity database. How should we model it? And once we have modeled it, how to write a table corresponding to that single entity. Very soon you will see that in our database we may have multiple entities, more than one. But for this lecture, we are keeping it very simple and we'll have a look at one entity only. And using that entity, we will create a database. And towards the end, I will also give you some idea about SQL statements. We will write some queries. And those queries are going to be very simple, but it will give you some confidence. You'll get an idea about how the queries are written in SQL. Okay, and yes, that will be fun. Let's move on. Now, we will discuss about relational model because MS Access is a relational model and MySQL is also a relational model. Even Oracle is a relational model. So a lot of database systems that you see around are based on relational model. So let's have a look at it, like what is relational model and why is that important? How did this model came into existence? So the reason why we will be learning about relational database is that the relational database is very popular. Most of the databases that you see around today and you might see in future are relational in nature. Okay, so you might wonder, like, why are the relational models so popular and why is this guy saying that in future also we might see relational databases only? Well, the answer to that is its foundation. So if you pay attention to this point right here, then this is about the person named E.F. Codd, who was a computer scientist. He came up with the concept of relational databases. And the relational databases are so successful because their foundation is in mathematics. Okay, so because of a very strong mathematical foundation, relational databases are very successful. They are very solid, I'll say. Okay, and that has been a reason behind their success. So this relational database is attributed to E.F. Codd, and he came up with this concept in 1970. And if you want to get into the depth of how this mathematical concept was mapped to the database design, then for that you will have to understand relational algebra. And relational algebra is little intense and is beyond the scope of ISC 305 and 503. So we will not look into relational algebra. But if you're interested in knowing about the link between relational databases and maths, then relational algebra is the way to go. So that's the link actually. And when we say relation in relational databases, then here the relation means the relations from sets. Okay, now the point is, fine, we will learn about relational databases, but how will the data be stored in a relational database? So that's the thing we will discuss about today. The data in relational databases is represented uh, in the tabular format. So we have concepts of table, which is technically called as relation in relational databases, and in that form we store all the data. So I have some examples, and using that example I'll tell you how a piece of information or a piece about an entity or the information about an entity would be stored in relational databases. Okay, so let me read this point. So a relational database is a collection of relations. So when you say relations in relation database, then that means table. So relations means table. Casually you can call table the way we call in day-to-day life, but from a relational database point of view, we will refer to table as relations. They mean the same thing. Now in a relation, which is a table, we will have the rows of the table and we will have the columns as well. And each row should be a unique. I mean, we should not have two rows, two duplicate rows. So these are some constraints on the table or the relation. I will explain that with the help of an example that I have. But let's move on. So the important message right here in this slide was that the relational models are the best database models till now, and then this model is because of E.F. Codd, who came up with this concept in 1970. And when we say relation, then relation means table. So the data in relational databases is represented in form of table. And this table is just similar to any table you must have seen. The tables will have a number of rows and columns, although we refer to rows and columns with different name here in relational databases. Okay, so if you want to look at the evolution, like how did relational model evolve, in 1970 the scientist Codd came up with this concept, and he was working for IBM. And then what happened? In 1976, IBM came up with a model, a database model, which was based on the proposal of Codd, and that relational database was called System R. Interestingly, around the same time, there was some research being held in a query language for database, which is called structured query language. So what happened later on, these two approaches or these two concepts, they got integrated. The concept of representation of the data in the form of table, and the concept of this query language, which is structured query language. And once these two things got combined, then the result was a very strong database system, which we kind of see as of today. And that resulted in a company named Oracle coming up, and Oracle was the first commercially successful database system which used relational model. So by 1979, Oracle came in with this concept of relational databases and SQL query language. Okay, and later on, after that, there was a lot of success in commercial relational databases, and it continued to dominate even in 1990s. Now what has happened recently? Recently, because of the object oriented programming, which has been dominating for a while, uh, people, they started thinking of adding the object oriented feature into the relational databases, so that designing an application with the relational database and the object oriented front end could become more flexible. So that's the recent thing, actually, the integration of the object oriented features into the relational databases. So that much of history, I believe, is sufficient for us. So let's move on with this history. Now, in the first few slides, I had this point that you need to read about data model. So let's try to understand what is a data model. So the data model that we will be using in this course is relational data model. There are other data models also. So let me use my pen, probably that will help. So wait a second. I should pick a pen, and I like blue ink. Alright, so I will use some examples for data model. Okay, so let's start with some examples. The first data model uh, was hierarchical. Hierarchical Hierarchical data model. It was by IBM. Then the next data model that came was called network. Alright, so hierarchical, network, and relational. These are the key database models that I think you should remember. Alright, wait a second. I would like to erase this part because I did not like my handwriting there. Sorry about that. Relational. Alright, now this is better. So the example of three data models which are popular are hierarchical, network, and relational. So we have this example. Now let's try to understand what do we have in a data model. What will define a data model? So as you have it here in my definition, it says that in the data model we have a collection of concepts. Alright, and these concepts are given for us so that we could describe the data. These are the concepts which will help us in describing the data as well as the relationship between the data, okay, and some constraints on the data. So there are three things in a data model which are vital. First, the concept so that we can describe the data. The second is the concept which will help us in describing the relationship between the data, and also the concept which will help us in imposing constraints on the data. So all these things are important, and I'll work on an example from the relational database point of view, and I'll tell you, like, how do we describe it, and how do we describe relationships, and how do we describe constraint in the relational data model. Okay, so have some patience. I'll explain these things to you with example. Now, because of these things, the data model has this part, the structural part, a manipulative part, and set of integrity rules. Now, what is structural parts? Let's discuss these concepts from relational databases. I may not give you an example right now, but I want to make it concrete. Like, what would be structural part? So you can guess, right? From here, let's start with the hierarchical data model. So as the name indicates, in the hierarchical data model, the data is represented in a form of tree. So that's the reason it is hierarchical. But this representation had some drawbacks, because of which people thought of removing those bottlenecks in hierarchical model, and they ended up with a model which was called network model. So in hierarchical model, you had a tree kind of a structure, whereas in case of network, it was a network kind of a structure. Now you might wonder, like, what is the difference between hierarchical and network? So in case of hierarchical, you can have only one parent, whereas in network kind of model, you can have two parent. Okay, so that's the only difference, but you don't need to get into that much of detail. I'm discussing this again because I want to make this structural part more concrete. Now the most important thing, which is relational here, let's pay attention to relational. So when we have relational data model, and you're saying that it has three parts, the structural part, manipulative part, and integrity rule. So what is the structural part here for relational data model? So it is a fact that So what is the fact here in the structural part? It says that data will be represented in tables. So that's the structure. Okay, so the structure is that every data that you have should be in the form of table. We don't have any hierarchy, we don't have a network structure, we have relational structure where the data, every data that you can think of will be in a table. Okay, Uh, that's the structural part. And not only the data, even the relationship that you have between the data, that will be also in a table. What is manipulative part? This is more interesting. So when you have what's manipulation, if you have the data stored in your database, then you'll start manipulating. Manipulating would involve the querying of the database so that you can get the information you're looking for, updating the database so that you can change a piece of information which is already there in your database. So how is this manipulation handled in case of relational databases? We use something called as SQL, structure query language. Alright, so relational database has that support. Like MS Access that you'll be using, you have a SQL query language, which we'll do today, and we'll start writing some SQL queries. And this thing is true for Oracle as well. Oracle is also a relational database. Um, and yes, there also the data is represented in tables, and we have SQL query. Same is the case with MySQL as well, and many other versions of relational databases. What is integrity rules? This is important actually. So probably we came across integrity rules. So what are integrity rules? So the point is, when you are creating a database, let's look at the example that we understand really well. We are designing a database for a university. Now, since we have to keep the information about, or the data about university in our database, we want to design it in such a way that it represents the real life picture of a university in terms of data. So whatever rules that apply to a university in real life should also apply to the data which we have stored in our database. So if you have those rules in your database, which makes it equivalent to the real life university, then we will say that the database has those integrity rules. So integrity rules are the rules in our database which makes sure that the rules that we have about a university in a real life is also applicable to the data that we have in the database. As an example, let's look at an example. That example will help you with this concept. So let's think of a rule that applies to the university database. All right, so let's assume that I am teaching this course ISE 305, and I am teaching that in fall of 2020. Okay, so I am teaching ISE 305 in the fall of 2020, and there is number of registered students. Alright, so since this course is being offered, if the students they are interested, they will register. Now the rule is that the number of registered students, they should be less than or equal to 150. That's a rule, because the room in which I will be teaching this course will have a seat limit, which is 150. So that's a real life scenario. I cannot have more than 150 student in my ISE 305, which I'll be teaching in fall of 2020. This is a real life constraint. Now, when I have to store the data in my database, I should make sure that any attempt which is being made to register students more than 150 should raise an alarm. Alright, so how do we do that? I need to write a rule which should check for this condition, and that rule would be called an integrity rule. Alright, and then for integrity rules, we have some concepts which are called constraints. Okay, so we define constraints in RDBMS. These constraints will make sure that the integrity rules are uh, obeyed or followed. All right, good. So let's move on. Now there are some terminologies that we need to understand, because these things will come uh, more frequently in our discussion now. Relation, as I explained to you, in relational databases, relations means a table, and this table will have columns and rows. Now these columns that you have in the table, they are called attributes. And what do these attributes do? These attributes will have the property of the table. So the point is that the table that you have will store the information about an entity. Okay, so let me use pen right here. So relation that you're calling, or the table that you have, it may be for an entity or a relationship. So relationship is something that will come to later, but I want to make this discussion complete. So for that reason, I'm introducing relationship right now, but for that we need to wait a little bit, maybe a week or so. So now, in the relational database, when you are having table, in the table we will store the data for an entity. Example of an entity, okay, student. Student is an entity. All right, so what you will do, you will create a table for student. I do have a table for students, so I don't want to create that here. So what will happen for this student that you have, you will have some properties. So let me write properties in parentheses. So student will have an ID number, like the way you people have your SPU ID, and the student will have name, and then student will have probably a status, address, sorry about that, okay. All right, so where are you? Name, and then status. I should be careful this time. Status, and here this is the address, physical address, right? Good. So now what is happening here, you will create a table so that you can store the data about an entity right now. So we want to store the information about student. Now student will have property, right? So this property that you have right here are these things. This is how we will describe or represent our student in our database, with the ID number of the student, the name of the student, status of the student, and address. All these properties that you see, which we are storing for a student, they are called attributes. Alright, so attributes, where are the attributes? Attributes are right here. Okay, ID, name, status, and address. These are all attributes of the entity student, and student is a table. Alright, great. I hope these things are making sense to you. Now what are domains? So the domains are attached to the attributes. Alright, so domains are attached to the attributes, and domain will determine what value an attribute will take. So let's take the example of name. Okay, so what values should we allow for a student's name? Well, you will say that, if you have some background in programming, Java or something, you will say it should be a string. Okay, and if you don't understand a string, even then you'll be able to guess that the name should be something like John Smith. All right, so here you can see that the kind of value which we expect for name should be characters, right? These are all English character, John, then there's a space, then John Smith. So for every attribute that you have in a table, we should impose some condition, like what kind of values are we allowed to have for that specific attribute. Like ID here is a number thing, so you might allow ID to be an integer number, or you might like to declare that as a string. That is perfectly fine. It is up to you what you want to decide. In some cases you should be wise, like the name should not be allowed to have number, because the name in real life is a string value with characters like John Smith. Similarly, status means what's the status of the student. Is the student junior, senior, and so on and so forth, right? So that's the status. Address is again a, the kind of address we people have, the physical address with street number, with apartment number, city, zip, and so on. All right. So what is a tuple? Now tuple is little interesting actually. Most likely this would be the first time when you're interacting with tuple. Well, if you have done some Python programming, then yes, we do have something like tuple there, but that tuple or tuple, people say tuple and sometimes they say tuple as well. So this is slightly different here. So each row in the table is called a tuple. Okay, so what is a tuple? Tuple is a row in a table. And what is an attribute? Attribute is a column in the table. All right, so please try to please start practicing this. Get used to these terms, because you are learning relational databases, so you should know what is an attribute, what is a tuple. Attribute is just the columns that you have in table. What is a tuple? Just a row in a table is called a tuple. And what is a relation? A relation is simply the table. Okay, good. Now what do we have here? Here we are trying to understand, like, what will we have in a relational database. So in a relational database you will have a collection of tables. Relations, when you are saying relations, means tables. Okay, you will have collection of tables, and they should have a distinct name. Their name should be distinct. You cannot have student, 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 5 student. No. Even if your university has, say, 30,000 students, you should have just one table called students, and each row will represent one student instance. So if you have 30,000 students in your university, then you should have one table called students, and you should have 30 rows for these, 30,000 rows for these 30,000 students. So each row will represent one student information in the university. Okay, and in that university you will have different tables. You will have table for students, you'll have table for professors, you'll have table for departments, and employees, and so many other things, courses, right, programs. So everything will boil down to a table in relational database. Now this is something interesting, normalized, right? So what is this normalized? I am saying that relational database is a collection of normalized tables or normalized relations, and they should have distinct names. So having distinct name, I think, is intuitive that you will get. Now normalization is something for which you will have to wait uh, till the end of the semester. So when we create a table, then we judge the quality of a table, right? So let me write this keyword which should help you. Quality. Normalization has to do with the quality of the table. When we want to judge, is my table good or not? Did I design my table in the right way or not? Because in the table I have to store my information. There's a concept of normalization, which are sets of rules. So normalization are set of rules which we use to check whether the table that we have created is in appropriate form or not. Does it look good or not? Are we expecting some problems because of the table design that I have currently or not? So normalizations, we have some normal forms which are set of rules which we apply on the table and check whether the table is in correct form or not. If not, then we fix that, we improve the table, and that involves splitting the table into multiple tables. But don't worry too much about this normalized term. I'm trying to explain what normalized is right now. It might be difficult for you to understand at this stage, but by the end of the semester you will understand what is normalization and what is a normalized relation. Okay, so let me create one example of a relational data model or relational data, right? So here what I will do, let me think about our university data only. University. Now let's see what will we have in a university relational database. As I said, the entities that I have are, I will explain to you what is an entity today. I have a better definition. So you will have students, let me call that students. You will have courses in your university. Courses, this is my S. Then you will have professors. You will have departments. I'm running out of space, so I abbreviated that. Okay, so these were the entities, and entities are kind of conceptual things, right, which helps us in modeling the data. And when you start implementing, then for each entity you will have a table. So for student, I should have a table. Let me create one. And it will have some attributes here. I will not write all the attributes because it is very difficult to do that here. Student ID, that's the important one. Let me write that here. Then you will have name, I'm abbreviating that, status, and then address. Okay, so you will have different entries here. It goes on. So here 101, let's think of as 101 as the ID of the first student, and John Smith is the name of the student, and then remaining fields you can fill. I have the second student 102, 103, and John Smith, and let's think of Mary, and Steve. Alright, so just think about it, right? This is a table which will store the information about students. So if I have 30,000 students, you should have 30,000 rows in my table named students. Similarly, you will create a table for courses. Alright, and all these columns, as I mentioned, these are called attributes. These are the attributes right here. I have attributes here. Each column is an attribute. I should have course number. Alright, and then you can write course name and so on and so forth. So ISE, let's start with ISE 305, ISE 503. Alright, sorry about that, it's not very clear because of the space, and you can add more courses. Alright, and similarly all the courses that you have in your university, they should be stored in one table, courses. So assume that I'm just making a guess, if we have 200 courses in Stony Brook University, then the size of the courses table would be 200. Similarly, you can create a table for professors also. Okay, think of different attributes of professor number. Okay, and similarly you can create one table for department also. You should have department number and so on. Alright, so our relational database, this is the point. Our relational database will be collection of normalized relations or table. So this relational database that you're looking at, which is university, it has a number of relations, all the tables here, and these are normalized. Let's assume that these are normalized. So we are representing data, right? So all this attempt of creating table for each entity is about representing the data. So we have a concept in relational database of representing data, which is in the form of table. So let me put this as this is data part, right? The concept for representing data is right here. Second would be or should be the concept for relationship, right? So relationship is a new topic which I can casually introduce to you, but more formally we will discuss later. Now, these entities that you have, the students, courses, professor, and department in a university, they are in fact related. Student doesn't exist in isolation. So is the course. Okay, so there is a relationship between student and courses. Similarly, there is a relationship between student and professor as well. Sorry, there's a relationship between students, courses, and professors as well. So let's try to understand a simple relationship between students and course number. So you students are taking different courses. So we have a relationship between student and a course. So a student, assume that there is a student named John Smith who is taking ISC 305 with me, and there's a student called Mary who is taking ISC 503 course with me. So basically we have a relationship between three entities: student, course, and professor. And that information should also be represented in our database. Now the point is, how will you represent this relationship between two entities? So the solution is simple here. Write everything in a relational database goes in a relation, that is a table. So right now I'm creating a very simple relationship which involves the course, the students, and the courses. All right, so I should write student ID as student number as ID and course number as course number. Okay, and then you can write the information. That's how we do it. Okay, let's not get into the details like how we should be doing it, but the message is that even the relationship that you have in the case of relational databases, that relationship information also goes into the table. How about data that goes into the tables anyway, right? You see that, you just saw that the students information goes to student table, course information goes to course table, professor information to professor table, department information to the department table, and the relationship goes into a relationship table. Okay, so in this data model, which is relational database model, we have looked at the concept for representing data, the concept for representing relationship, and let's think about the last part, which I think I should take here, that is about integrity rule. How do we enforce integrity rule? Well, so there are a number of ways in which you can enforce the integrity rules. Integrity rules are the rules that are there in the real life of an enterprise or of a university, which we want to make sure that we are also following that in our database. So what could be the rules like? You need to think about the domain. Okay, the value of, sorry about this, eraser. Okay, so here we should be concerned about the value. As an example, for integrity rule, it could be value of ID, like student ID, right? What's the ID number of student? So there is a rule in the way the student ID is given to you. Alright, so that rule should be followed, and that will form a part of integrity rules. And yes, it is possible to enforce integrity rules in relational databases while we create the table. So during the creation of the table, you can use constraints. So here the constraint that we are discussing is called domain constraint. Why is it domain constraint? Because you are telling like what are the domains, what are the values which are allowed for a specific field. So right now we are looking at the ID field. What values can the student ID take? So that will be dependent on the domain. So you will have to define a domain, and if you do that properly, it will be taken care of. Similarly, course ID would be different from the student ID. So how do we define course ID? You need to write some rules so that the course should be described like ISE 305. So first three are the English letters followed by three numbers. CSE 305, CSE 114, right? So this way, this is how we define the course number. So for integrity rules also, we need some ways, and we have constraints are used to define the domains. All right, I think this much is sufficient. I don't want to add too much of details right now. All right, so now this is an interesting slide because here you have a much better looking example, and we have the example of a table, and this table is storing the information about the student. Excuse me. So it's a relation name or a table name, that is student. And look at these columns. I have 4 columns. The first column is the ID field of the student. The second field has the name of the student. The third field has the street address of the student, and final is the status. Is the student fresh or the student senior or what? Okay, and here you have 4 records. So in my current database, which has a table called student, I'm only keeping 4 records. And as I told you that the technical term for a row in table is called tuples or tuple. So you have one tuple here, the second tuple here, third tuple and fourth tuple. And ID is one attribute, name is the second attribute, address third one, status the fourth one. So attributes are the column headers. Okay, so these are the attributes. Good. Cheers. Now tables, right? So what do we want in table? The set of rows should not have duplicates. So it's a big rule. All right. So that's the in a way definition of the table as well. Set of rows with no duplicates. All right. So this is very much different from the second one, right? Every field is different in first tuple and the second tuple, and each row describes a different entity, and I should say instance. Let me add that, entity instance. All right, let me explain what is entity and what is an entity instance. Well, for entity anyway, I have a definition which we will get to later, but let me tell you what is an entity. Entity is something which exists independently, and it is something which is concrete, and it can be defined with set of attributes with some properties. So here the entity is student. We just saw that, right? Student entity. In this example that you have, entity is student. But these different tuples that you see, these tuples are entity instances. Okay, so this is first entity instance. First entity instance, who is John. This guy is second entity instance. Here you have third entity instance, fourth entity instance, right? So instance is important. Whereas the whole table, if you're looking at, which is describing a student, will correspond to one entity. Student is an entity, and different students who are there, whose information is stored there, they are entity instances. So each row describes a different entity instance. Each column states a particular fact about each entity. So you should agree with me. This column that you have on address, the column with the name address, is in fact storing the address of different entity instances or different students who are there in my student table. The name column or the name attribute is storing the name information or the fact. The name is an information or a fact about the student. Okay, and this is important here, each column has an associated domain, right? So this is important for us to understand. What will domain do for us? All right, so ID is interesting, right? ID will have some numbers, and you can look at your ID. Probably it's 9 digits. If your ID is 9 digits, then we cannot have an ID value which is more than 9 digits, or maybe less than 9 digits, right? And also in ID, the SPO ID that we don't have character. These are all numeric. We don't have letters. These are all numeric characters. So these are some rules that apply for ID. So a valid ID should have the corresponding value which is allowed. Status is the most important or interesting domain right here. So the domain of the status, right? So what is the domain? So status will have the value either fresh or sophomore, junior or senior. We do not allow any other value for this field, which is status. All right. So as an example, let's think about a table, right? Let me add a table which is called transcript. All right. Assume that we have a table known as transcript, in which I'm storing the information about the grades of different students or all the students that I have in my university. So in this transcript, I will keep student ID. I'm calling that as SID. Course number, let me use that C hash for that. I will keep semester. I'll keep year, and then I'll grade. And when I'm saying grade, that means a letter grade, right? So why am I giving you this example? Because I want to emphasize the importance of domain, right? So what would be the domain of this grade attribute? Well, you know that, right? The different grades that a student can earn in a course would be either A or A minus, B plus, B, B minus, C plus, C, C minus, D plus, D and F, right? These are the only grades that I remember. Okay, so I apologize if I miss any letter grade which we have in our system, but we need to enforce in our database that if somebody is entering a grade like A plus, right, any attempt to enter a grade like A plus should result in an error, because we do not have A plus grade in our system. Alright, so what are these values? These values are defining the domain of the grade attribute. What is a domain? Domain means what are the allowed values for the attribute. For grade attribute, the allowed values are these grades. You cannot have anything beyond that. Alright, so I hope that these things are making sense to you. Let's move on. Now, what is this relation? The same thing, right? The table is called relation in relational databases. And in the relational databases, the row would be called a tuple, column would be called an attribute. Now, this is a very interesting observation. The values in a tuple are related to each other. It should be intuitive as well, but please try to understand what we are trying to say here. So John, let's go to the column where we have John, right? John is right here, the very first tuple. John has the ID which is 1111, and John has the address which is 123 Main Street, and he's a freshman. So the point is that all the values that you have in a tuple, those values are related with each other. So this address that you have here is applicable to John. So John is related to this address. And similarly, ID is related to John. So that's the thing we are trying to say right here. Values in tuple are related to each other. John lives at 123 Main. Okay. Now, let's look at modeling. What do we do in modeling? And in fact, you will also do modeling in your project. So what do we have to do in modeling? So modeling is a conceptual step, I'll say, where we try to translate the requirement that a client has put forward for the project into a model. Okay, so why do we need to do that? See, when you know the statement or the requirement of the project, you want to make sure that all the requirements that we have of the project are properly captured in a conceptual model, right? So that's what modeling does. And why do we want to do that? We want to make sure that every detail which has been mentioned in the requirement is captured in the model, right? We don't want to miss any information which was conveyed to us but we lost in the process of implementation. So and why do we want to do that? Because database that you're designing must reflect the real world enterprise, right? So if you were given a project to design a database for a university and you missed out a good chunk of the statement, then probably that's not good scenario. Okay, so a database must mirror the real world if it is to answer questions about the real world. And the best approach for that is to use some modeling. All right, because modeling tools are very handy. You will start doing it in your project and you'll realize how important and how interesting and valuable these models are. Okay, good. So now let's look at what are the different modeling techniques that we can apply in databases. Excuse me. So we have object modeling, which is done for object oriented software designing usually. And in databases, ER modeling is very popular. ER stands for entity relationship. Okay, so there'll be chapter on ER diagrams. I'll do that. So the kind of modeling which you will have to do for your project will be entity relationship modeling, ER modeling. Okay, so let's get into the ER modeling and try to understand how do we model a database using entity and the relationships. Okay, and this is a very important thing for you people to know. An information system major student should have a decent understanding of data modeling. Alright, so let's start with an entity, right? So entity is something which probably I introduced to you in the very first class, probably with not the best definition, but now I will attempt to give you a concrete definition so that you have a better idea about what entity is in the database. So entity is a thing. Wait a second, I should change this to pointer. Okay, an entity is a thing or an object with an independent existence. So let me spend more time on this because in my experience, whenever I teach this course, I check the students whether they understand entity and attributes well or not. And at least in 50% of the cases, initially I found the students messing up with the understanding of an entity and attribute. So an entity is a thing or an object with an independent existence. Please pay attention to independent existence. Okay, so as an example, what could be an entity? Entity could be something physical, right? What is physical? I mean something that you can see, right? You see around, like person. We can see person, we can talk to a person, right? So person is physical. Similar is car. Car is physical. We see that. We drive car, right? House is physical. We live in houses. but the entity could be either physical or could be conceptual as well. So this conceptual thing is interesting, right? So why do we call something as conceptual? Well, a job is conceptual. I will say, sorry. You'll say, why is that conceptual? Can't you feel the job? Well, I'll say that job is a kind of responsibility, and I have a job. I teach, and I make sure that I'm doing my job properly. But if someone says that, does a job look like the physical entities like person, car, or house? Did you see a job walking somewhere? Did you see a job sitting somewhere? Well, that doesn't apply, right? So I'll say yes, job is something which is a real entity, but it is conceptual. We cannot see and feel. All right. Similarly, about university courses. So from database point of view, let's try to understand the difference between a physical entity and conceptual entity. Okay. So university course, well, fine. IC 305 and IC 503. These two are two courses. These are conceptual, right? We can't see a course sitting somewhere, or course walking somewhere, having coffee or something like that. Okay, so that's the point, physical and conceptual. But yes, a job has the properties. Job will have the attributes like job title, job number, salary, department, you know yeah. Similarly, university course number, course name, the name of the department that is offering this course, number of credits, right? There are so many. Okay, so I hope now you understand what is an entity. Entity is a thing or an object with an independent existence. This is very, very important. Okay, so why let me see if I can go back right here. So I often ask this question to my students to list some entities and attributes. So sometimes I have seen students coming up with the entity as name. So name cannot be an entity, right? Try to understand. Name cannot be an entity because name does not have independent existence. If you say that the name is what is it, Kimberly, right? So I'll say, what is that name? I may ask you, right? Is that the name of a person, the name of a professor, or the name of a place, name of a restaurant? There are so many things, right? So the name is not independent. Name is the property of some object. This object could be a person, this object could be a place, could be a tool, right? So these are properties. Properties are defining an entity. Entity is independent, whereas attributes are defining entities, right? So I hope these things are making sense. So please look around, okay? Look for some examples and try to figure out what is an entity and what is an attribute. Okay, so if you're really following me around along, then let me give you an assignment. Okay, so this assignment is not something that you have to submit. This is thinking assignment, which might help you in your project and also in your exams. Let's think of about an e-commerce portal like Amazon. Think of different entities that we have in Amazon. Okay, and for each entity, think of different attributes that you can find. All right, so if you want to discuss that with me, I'll welcome you in my office hours. Okay, but given you the assignment, thinking assignment. Okay, all right, so let's move on. What is an entity? Okay, it usually corresponds to something concrete in the domain of the application, right? Professors, students, department, courses, these are all some concrete entities in the university system. Now, right here we will now discuss how do we represent these entities in our model. That's the important thing. We have to learn modeling, right? So how do we model? So in the ER model, the entity is represented by a rectangle, right? So here we are looking at an entity called shares, right? Probably you know what these shares are. Right? shares related with the stock market. Every company has a share. So that's the share thing that we're interested in. We want to model an entity representing shares, right? So I might ask you this question, that is shares physical entity or conceptual entity? Think about it, right? Good. So an instance is particular. Okay. So this thing I already highlighted. An instance, which means entity instance, is a particular occurrence of an entity, and it corresponds to a row in the database table. So I did explain that to you in the previous slides. Okay. All right. Now this is all modeling, right? We are in modeling right now. So you won't you won't see any table. You're just looking at a rectangle, and this rectangle has been named shares. So this is the representation of an entity in our modeling, and we are modeling an entity named shares. Now all these things that you have listed here in the shares are the properties of this entity, and the properties are called attributes. Okay, so here we have attributes here. So also referred to as properties, which I explained. An attribute is a discrete data element that describes an entity. Okay, so these are few things I want you to understand well, because very soon we'll have quiz, and then we'll have midterm as well, then we'll have finally a final exam. I ask these kind of questions in exam, and my uh, motive behind asking these questions is to see whether you followed these things along or not. Did you understand what is an attribute or not? So the best thing would be if you uh, remember the definitions as I have in my slides. Otherwise, doesn't matter. You don't need to memorize. You should have the understanding. So you can, may write something parallel to the definition. So what is an attribute? You can say attribute is something which describes the property of an entity, right? It is referred to as the properties. An attribute is a discrete data element that describes an entity. That is fine too, although it's more technical, sounds more technical, but I'll be very happy if you could write something like this. And the most important thing right here is that attribute names should be meaningful. Okay, so this thing which is like attribute names being more meaningful, relates with the notion of programming language. So when you write a program, then in the program also we have identifiers, or you may like to call that variables, to keep it very, very simple. Then in programming you are told that the variables that you use in your program, they should be meaningful. So if you're writing a program which has to compute the interest, which is a financial kind of program, then make sure that your variables that you're using in the program are meaningful. So you should declare something like interest rate. So rather than creating a variable with the name like x, y, and z, it will make more sense if you declare your variables as amount, interest, and interest rate, right? So name your variables such that the variables are meaningful. Okay, so that it is convenient for you to write that program, and also it is convenient for anyone else to use your program. Okay, this is a very valuable suggestion for people who are related with software. Okay, now this is even more important. Having the meaningful attribute name is even more important in databases. Why? Because look at this shares, right? Shares is an entity, and the different attributes that I have named it in such a way that the name will convey an information that the first column that you have in this entity will be having the value of the code for the shares. The second column that you will have would have the data for the name of the shares. The third one will be about price. The fourth one about quantity. The fifth about dividend. Last about PE. Alright, so the message is that the attribute names should be very meaningful. Otherwise, if you create a table like shares and keep the first attribute as x, second as y, third as z, nobody will know what do you have in x, y, and z. Okay, so that's the message. They should have meaningful names. Attributes should be having meaningful names. Okay, so now we are moving to a very important attribute, or the sets of attribute, which are called identifiers or primary keys. So this is very important concept. Now let me read these points, and because I don't want to cross my boundaries, so I would like I would try my best to remain uh, you know in the scope of ISC 305. So for that reason, let me read it. Now every instance of an entity, which we mean as the row of a table, must be uniquely identified. Okay, and the identifier can be and an identifier or a primary key can be used can be one or more attributes. Better to use an identifier that does not relate to the domain attribute. And a linear. Okay, so fine. Let me take you back to the example that I have. I don't have an example here, so I will have to take you back to my previous slides. Right here. Okay. Now, we are looking at this table, which corresponds to the student entity, and we have different entity instances. We have 1, 2, 3, 4. 4 instances means 4 tuples we have. Now, all these tuples, they should be identified uniquely. What does it mean? Identified uniquely means that we should not have duplicate information. Alright, and in this attempt to uniquely identify each tuple, there are some attributes. Okay, so there are some attributes in the table with the property that these attributes will be unique across the table. Alright, so this attribute or the set of attribute which is guaranteed to be unique across different tuples are called primary key or the identifier. Alright, so one more time. In a table, let me keep it very simple and let's use just a table. In a table, we have some attribute or subset of attributes, one attribute or more than one attribute, which taken together make sure that they are unique across different tuples, and those attribute or set of attributes is called primary key or identifiers. Alright, so what I'll do, let me go back to that slide and probably I'll have to use an example. Okay, so I don't have space, but I'll find out some space in some slide and I'll write that. So here, you have shares. Now, assume that this share data which I already have on the blackboard, you will have to download that, and we will work on that using MS Access. Now assume that the same shares was pulled in MS Access and MS Access added a field called ID. Now a field, or see, field is another keyword for attribute. Now this attribute or set of attributes which are guaranteed to be unique across different tuples are called primary keys, and there is a symbol called star before that, right? So let's look at this one and then I look at that one. So this was our original shares entity, right? This share, same thing. Now we are adding another information to that. What's the additional information? In this additional information, we identified that out of these different attributes, I have one attribute like a code which is guaranteed to be unique across different shares that I have in my shares table. So this code will be unique. Okay, so for that kind of an that particular attribute is called primary key, and we put a star before that so that we can distinguish that this is the primary key, the remaining are not. So I can have the duplication in the price. I can have the same price for multiple shares, but I cannot have the same code name, code number. So take any two shares from my shares table, their code will be different. Why? Because code is a primary key. So every instance of an entity, which means the row of a table, must be uniquely identified by the primary key or the identifier. Okay, so primary key or the identifier means the same thing. Alright, so now there are certain rules about identifiers, like should I use the identifier from the data itself? So here the code field that you have is coming from the data, right? It's a natural key, right? Natural key means this field was already there in my shares entity. I did not add that up. But if you did the exercise that I asked you to do in the last lecture, and I asked you to, let MS Access add a field in your table, then the Access will add a field, and Access will say, what I'm helping you, I'm adding another field in your table which I'll use as a primary key. You'll say, okay, fine, yeah, please, thank you. Excuse me. So that will happen. So MS Access will add another field to you, which will be a primary key again. So now we will use this as a primary key. So that's the point about it. It's always better to use an identifier that does not relate to a domain attribute. Okay, so this ID that you have, ID field, which MS Access is adding to your record, is better because it does not relate to any other attribute. This is something which Access is adding to it. Okay, so that will be better. Alright, so a leading asterisk denotes an identifier. Sometimes we use other notations also. In some cases we underline the attribute which is primary key. So you should work on it, right? Make sure that you understood what are identifiers. Very, very important. Now we'll look into the naming conventions. There are certain rules. Although these are not universal standards, but it's better if we learn about these, and it's better if we stick to that in our ISC 3 or 5, because we'll learn a good practice. Okay, so please learn this rule and try to be consistent in your projects and in the assignments that we'll have. So we will be using a camel case convention of naming. So what is a camel case? Well, it relates with the structure of a camel. So you see these two things, right? So that is used for naming the compound words. For the simple word, single word, we don't have a problem. But camel case is handy when you have compound words and you want to combine those words into one and use that as either the table name or as the attribute name, right? So how should we do that? So we have upper and lower camel case. So how do we use upper and lower camel case? When you have to combine two words to make one word. As an example, just look at camel and case, right? Camel is one, case is the other. So we can combine these two terms like camel and case into one, which is camel case with no space in between, using either the upper camel case convention or lower camel case convention. So in upper camel case, we keep the first letter of both the words as capital. So C is capital here, and the C of the case is also capital. So this is an upper camel case. In the lower camel case, the first letter of the first word is lower, right? So here the first letter is lower, whereas the second letter is upper. So we call it as lower camel case. In upper camel case, the first character of the first word as well as the second word are in capital. Very simple, okay? Now, what is the convention that we have to use in this case, in this course rather? The tables, we will use upper camel case for tables, and we will use lower camel case for columns. Okay, and then table names should be plural. So if you are creating a table for students, you better call that students, and similarly for course, you call that courses, and attribute name should be singular. Okay, so the course number should be course number, not course numbers. Okay, so which is intuitive as well. And we would try our best to keep the primary key field as ID. We'll name that as an ID only, because by ID we will understand that this is a field which will be unique across different tuples of the same table. And we will try to avoid acronyms if those are not well known. Right, so we can use PI because PI is for principal investigator, and if you know that PI is something that everybody knows, so avoid using acronyms if that is not very popular acronym. Okay, so now this is an exercise which I always say, are we on track? And today I will not do this, and this is an assignment for you. What's the assignment? Modify your SBU awards database so that it conforms to the rules that I just mentioned. So what will you do? You will have to, name your table in such a way that it is in upper camel case, and use the attribute as the attribute names as in lower camel case, and then make sure that the attributes look good now. So what you'll be doing, to be more specific, ID should be left as ID, and originally if you look at the source file, that means the data file that I shared, we have a field called our AWD and then a space and number. So you might like to change that to award number, and this is a lower camel case. A is small now, and we will say award so that it's more readable and people may understand what is this field about. AWD might be a little confusing, like what is this AWD, but when you say award, then it makes more sense. Award, then space and number. Okay, award PI full name, so it's a very lengthy field that we have in the original data. You might like to change that to PI name. Alright, so a small PI name. Small PI name I will say is better because it is lower camel case. We want lower camel case for the attributes. Award type could be simply type. Award organization could be renamed as organization. So please use this logic and reformat your table and figure it out. How can we change that in MS Access? Now these are some exercises which we have to do. I'll see how far I can go without doing that exercise. Let me cover that in the lecture. Anyway, I'll do a demo, and from the demo I'll tell you how to do it. So now we will be working on a different file, a different data I should say, shares. So you must have seen some examples with shares. So I shared this shares.xls, which is Excel file on Blackboard, the same place where you found the SBU award data. You have to download that and you'll do the same exercise. So you can create a table the way we did. I will do that as an exercise. Now right here we are showing you like how can you change the data type. So in the shares file that I will be working on and that I have shared with you, we have these different attributes. The ID, which we kind of added using MS Access. Then you have code, share name, price, quantity, dividend, and PE. So these are the field names, and each of these fields have specific data type. So this data type is something that you can connect to the domain. Okay, so what kind of value is allowed for ID? What kind of value is allowed for share name? What kind of value is allowed for code? What is quantity? What kind of value? Quantity cannot be text, right? It has to be a number. So what will happen when you create a table? Then MS Access will by default identify the best possible it can the different types of the field that you have in the table, or you had in the file, and it'll create a table with the appropriate type. So ID will be a number, and that's fine because number ID is something that MS Access is adding. Code, it recognized as text, that's okay. Shares as a text, it identified price as number and the remaining as number. So now it is up to you. If you want to change the data type, you can do that. Okay, so when you click this thing right here, then you should see another window popping up. So here the price is a number, and when you click that, then you'll see another window being popped up. And this number, the window that you have, the next one, will give you more information about this field. So right here you can change. Right, when you click this one, you got this property window. Now you can change the size, right? Do you want it double or you want it something else? Do you want to format it? You may specify how many decimal places do you want by looking at the decimal places, right? And then there are so many other options available to you to play with, and all these options to relate to the data type of an attribute. So in this example, our attribute is price. For price, you click this thing and you got another window with the details. Okay, now are we on track exercise? So this is something I'll do as a demo. So you have to create a new database from shares.xlsx, which is posted on Blackboard. And well, if you have a textbook and you're reading the textbook, then you can find its reference in chapter number 3. Now what we have to do, we have to use the spreadsheet column, name as at your attributes names, use the default types. So here we will not change anything. We'll let the MS Access decide what is the best type to associate with each attribute, and we will use an ID attribute as our primary key. We will not use the analyze wizard. Okay, so let me do this and then we will do the remaining things. Okay, I will discard these modifications. Here I go. I should say access. Let's take and say blank database. Let me call this shares. Let's say create. Now I will say external data, say new data source from a file. I'll say Excel file and have to browse. It's on my desktop, summer 2020 data sets, and here is the shares. I'll say open, say OK. Alright, now the same thing, if you did that exercise for the previous data set, you have to do the same. It's asking like, should I use the first row of your file as column headings? You will say yes please, right? The first row has the column headings. We'll say yes, then it will go next. Now this guy is saying like, do you want to do any changes here? We don't want to. Then now this is saying that, do you want this favor from me? I can do this thing. I can add a field primary key. We'll say yes please, go ahead, because the assignment says so. And well, saying like, should I call that shares? We'll say yes, and we should not click this box, right? Anyway, we'll do that towards the end of the semester, not now. We'll learn something in the process. It's too early to pick this one. Okay, so we'll say finish, close, and let's click this guy, right? Yeah, we have the table. Okay, so this is an important table because we'll do a lot of stuff on this table. In fact, we'll be writing a query using this table today. So the exercise says that we should adjust these columns. Let's do that. All right. And not much to do for the attribute names, because attribute names look good to me. So my point is, since these are simple attributes, and these attributes, they look to me as an proper camel case, right? So fine, firm name is in the lower camel case, price, quantity. Well, okay, so everything is perfect, right? Good. Now what's the other exercise? All right, so okay, let me show you this thing. When you go to home, right here we have the option. You are looking at data sheet view. When you say this thing, you have two options: data sheet view or the design view. So for this table that you created shares using the share source file, you're looking at the data sheet view. If you want, you can go to the design view also. And in the design view, let me pull this thing a little bit. Okay, so in the design view we have different fields and their type. So ID is an auto number which Access did for us, so we should not be concerned about its data type. How about code? So see, when you click this one, I had a and this as these things were showing up on my screen. When I said code, see, it changed, right? Why? Because the type of code is short character, and now this thing right here that you have is describing the data type. Okay, short. If you want, you can change that. You can change this the data type to so many options available here, right? So if you're not happy with the data type that MS Access picked, you have the freedom to change that, but do that with proper caution. And right here, when you're saying short text, then these are few things which we have available: field size, format. Okay, so it has 255 characters right now. If you want, if you think that I may not need those many characters, you can reduce that right here. Alright, then we have various other options. It is for us to figure it out. Alright, and then form name, price is a number, right? So for number, again, you have the format, you have decimal places. If you want, you can change decimal places here. Okay, so but we are not doing anything right here, but you can specify. Once you say 2 decimal places, then the result would always be shown till 2 decimal places after decimal. Alright, so these are few things you can do in the design view. We'll go back to datasheet view. Alright, so resize the columns. We've done that. Look at the table in MS Access design view. I did that. So please do that, okay, at your end also. I request you to do it. Alright, design view we just saw. Now this is a discussion on data types. So I have given you the different data. I gave you, I was okay. One more time, right? Anyway, we are discussing it. Go to the design view, and if I pick one of the attribute like price, then you can see that right now price has been picked as the type which will have number. Number means it is allowing it to have numerical data and numerical data with decimal and decimal and some values after the decimal also. That means fractional numerical value where you will have decimal and it's not whole number kind of value. It's numerical with possible decimal and digits after decimals as well. You have, other than this type, you have so many options available, right? So we need to understand about the data types. So these are all data types: number, short text, long text, large number, date, currency, auto number, yes, no, OLE object. Okay, so these are the supports which we have available in MS Access, and it will help us in storing that kind of data in our database. So my next few slides are about that. It is about different data types that we can store in the database that twin MS Access. So why is this data type important? Because it will let us, define the kind of value that we are dealing with. Okay, so it's a classification of the data. Like the if you have a number of credits for a course, so the number of credits is a digit. It's an integer value. We cannot have fractional value for the number of credits, right? So these data types will help us in declaring an attribute in such a way that the attribute is compatible, to the type. So a classification identifying one of the various types of the data types determines the possible values that the data type will have, the operations that you can perform on that data type, and the meaning of the data, and there are other issues also. So this slide, I'll say you should simply read and try to make as much as sense possible. The whole message about this slide is that we need these data types because data type is important. So if you are dealing with a field that is currency, better use it as a currency. If you have field in the data that looks like a date, please make that as a date. If you know MS Access is not smart enough to pick that as a date field. If you have binary one where you're expecting yes or no, please pick that as yes or no data type. So this is something you learn with an exercise, but the message is knowing the data type is very important for the attribute of the entity or the table. Alright, so now what are the different data types which are available in SQL in general? So we have the support to represent string values. That means the name is a string, the name of a person is a string, the name of a department is a string, or your street address is a string. So we do have support for storing the string data in the SQL. So here this slide is about general SQL. We are not saying anything about MS Access. We have a separate slide on MS Access. Okay, so you can have bit string also. Bit strings means you have zeros and ones. You don't have other characters. You have the type integer, which will store and the whole values, right? Like the age of a person, if you're representing that as an integer. Your number of persons in family, number of students in a university, number of faculties in a department. So all these values are integer. Okay, floating point is one where you are expecting decimal values like 25.789. So if you have a data where there's a decimal and some digits after decimal, that means a fractional numerical value, then you should go for floating point. We have another type which is numerical and numeric and decimal, that is also similar to floating point. Date is important so that you could store the date field and do appropriate operations. So date field we should identify. And these are the standard SQL data type for we have for integers two versions, int and small int. With integer and small int, with integer you can store a really big integer, whereas for small int you will be able to use a smaller integer value. You have float and decimal. Float and decimal are for the fractional values where you have decimal. Then the float and decimal, they are defined with the help of precision. So write p is precision here. So when you say float p, that means it can it will have p binary digits precision, right? So these are some details that are up to you if you want to follow that. Similarly for decimal, p and q, it means that it can have at most p digits in your decimal representation, and the q that you have, these many digits you will have after the decimal on the right. Now for string you have three types, char and varchar. So char is interesting, where if you say character 10, that means doesn't matter whether you have 10 characters or less, it will anyway use 10 characters for your attribute. So that is efficient, but efficient in terms of speed, but is not efficient in terms of space. It will waste the space if you don't have the string with that length, right? Varchar is more flexible. So if you set that varchar 20, and that means it will store 20 characters for that attribute. But if for some reason you had only 10 characters in a specific tuple, then it will not use all 20, it will only use the 10. So this is more efficient. Varchar is more efficient in terms of space, but it's slower compared to char. You have similarly text. Text has the capacity of storing 65,535 characters. Then you have date and time. You have a field called date that represents the date in the format of five fields for, sorry, initial four fields for year, then the two fields for month, followed by last two fields for day. Similarly, you have for time, which is hour, minute, and second. You have timestamp that combines date and time, and you have more options. So this is an assignment that I kind of have in the second or third slide in this lecture, where you have to go to that link and read about the data types which we have in MS Access. So MS Access supports binary, which is 1 byte. You have bit, which is 1 byte, which can store yes or no. Then you have tiny int, 1 byte. Money, you have date time, you have real, which is 4 byte, float 8 bytes, small int 2 bytes, integer 4 bytes. So here small int, you can see the range that small int has. It can represent the smallest integer, which is minus 32,768, and the biggest integer, which is 32,767. So if by any reason, if you are thinking that in your data you will have really big integers, then better you go with integer rather than a small int. Similarly, you have for decimal, you will use 17 bytes. Text has 2 bytes. You have some data types like image, and you have character. Alright, so please have a look at this. There's not much to explain. This is something which we have to learn by practicing. Okay, so now we have another, are we on track kind of an exercise. Using the shares table, which we have just used, select more appropriate type for those attributes whose type can be improved. So this is for you to think about. The Access did its own job. Access figured out the type for each attribute. Now, the thing is that can you improve those types? If yes, then please go ahead. Alright, so well, there are suggestions also, right? So it's not that I'm just asking you to do the exercise. I'm asking you to do this exercise and make sure that you did something like this. I'm also providing you the answer. So what's the answer or the hint? Limit the field size of code to 4. Change the type of price attribute to currency and 2 decimal places. Change the format of quantity to number. Change the type of dividend to currency to decimal places. Change decimal places of PE to 0. Alright, so should we do that? Yeah, why not? So let me go back to this thing. Limit the size of the code. So we have code right here. I'll go to the design code. It has 255 character size. I'll make that 4, right? That's what you were asking. Okay, yes. So I'll go back to, it will say, it will have a warning like, do you really want to do that? I'll say yes. Yeah, it will say that you may lose the data. I'll say yes, I want to go that way. Alright, so if you want to double check, yes, this has been changed to 4. What else? Change the type of price attribute to currency. Alright, where's the price? Okay, right here. Price is number. We want to change that to currency. Let's do that. What else? Change the quality on the format of quantity to number. Quantity is a number already, right? So we don't need to change anything. Change type of dividend to currency. Okay, so there's another thing that I did not. Dividend to number is saying we should change that to currency. And here when you're doing currency, this guy is saying that we should also fix 2 decimal places, which I did not do in the first one. So decimal places right here. Okay, we can change that to 2. I should have done the same for price also, right? For price I did not change the number of places. Let me do that too. Done all the changes that this guy is asking me to do. Change the decimal places of PE to 0. Where is PE? Right here. Decimal places, I'll make that to 0. We are set. I'll go back to datasheet view and it will give me some messages. I'll say yes, please do that. It will say that you lose some data. I'll say fine, I have thought about it. So now you can see the change, right? You can see the symbol dollar, which means the price is a currency now. Dividend is a currency as well. Initially it wasn't showing dollar sign. Now dollar sign means that it is a currency. You can go back and double check that the changes that you made is effective. Alright, so we are doing good, I believe. Let's move on. Alright, so how can we insert a row within the axis? So it is simple, right? Because it's just like the point is, how do we insert rows within axis? So it's very simple. It's just like an Excel. We can do that. Now is the point where we will learn the SQL thing. A very little bit of SQL stuff, right? So the point is, okay, let me do that exercise. Okay, just once. So let me add one new code here. TCS, Tata Consultancy Services. Okay, and then I will add some 30. $30, right? Quantity 2,000. Dividend 1.5. PE, I'm just putting some arbitrary values, right? So yes, the point was, can you add insert rows? Yes, you can insert. I did that just now, right? I added one tuple. So these are all tuples, right? 1, 2, 3, 11. 11th is the one that I added. And I did not add anything for ID. MS Access added that for me. Okay, yeah, so insertion is easy. Now we'll learn about the SQL thing. Select statement. So what is the purpose of select statement? Select is the statement which is very, very popular. Often I'll say it's the one that people use the most. And it's used to extract some information out of the table. Okay, so select gets really, really complicated when you add more clause to the statement, and these are the clauses we will learn in the next few lectures. So the first select that I'll be writing would be fairly simple, but as and when your query demands gets complicated or complex, when your query gets complex, you need to have the other clause which are used along with the select statements, like where, group by, having, order by, and as. So what happens actually, writing these SQL query is fairly easy, and yeah, it's easier to learn as well. But what happens, um, these SQL queries are actually translated by the DBMS to the query execution plan, and this query execution plan is something that DBMS ultimately implements. So the simplicity that we see in writing the SQL um, is achieved because of the fact that we have some components in DBMS called the query execution plan or query engine that, you know, takes your query, translate that to the query execution plan, and that's how these queries are implemented. Now, how should we create a query, right? So let me do that exercise and then I'll walk you through my slides. So when you have to create a query, my query should be based on this table that I have here. I'll go to create. We use create for tables and created a table, right? So now we have to create queries. So from home you go to create, and create you go to query wizard. So we have two options for creating a query, either using query design or query wizard. Let's use query wizard for the time. Click that, and then we will use simple query wizard. Okay, say OK. Now it will show you the table. We have only one table, so let's write a query on that table. So now life is in MS Access is slightly different. It's very easy, but it has its own way of doing it. So if you want to do it differently, probably it won't work out. But being simple, we have to kind of, adjust to it. So what we do initially is that we will use any one of this arrow or all these arrows. Okay, so what has happened here, let's go back. This is what you were looking at. Now query wizard is saying that what is it that you want to query from this table. Do you want only the result for ID? If I say this, then ID will be on the right hand side. If I say price, then even price will be added. Dividend will be added. And if you want these arrows, then everything will be added to your right hand side. So what will happen here, you are specifying all those attributes that you want to query from your shares table, and then what it will do, it will create a corresponding query, SQL query for you. Okay, then you'll say next, and you'll say next, and then you'll say finish. And what you're looking at is the result of the query. So what we have to do, we have to go to home, and the query is being selected. Make sure that you have selected queries, then only you'll be able to see these many options. Datasheet view, which is similar to the datasheet view that you had in the table. I have a SQL view and I have a design view. Datasheet view and design view are similar to the design view and datasheet view that we had in table, but SQL view is different. And this is where we will be typing our SQL statements that we write. So how it works in MS Access, this is the way you have to go about. When you want to write a SQL query, you will have to first create a query the way I did, which is by using a GUI, selecting those attributes, like I selected ID, I selected price, I selected dividend. And what happened, using that GUI, MS Access gave me the output. Now what I will do, I will write my own queries here. If I have to learn writing queries, then I should delete all these things and I should write my own query. So the first, let me tell you about select statement. We use select, SELECT, followed by the attribute names. So what are the attribute names here? Code. So I want the value for code. So let me say select code from, and I should say table name. Table name is shares. So that's the simplest possible SQL query that you can write. What are you saying? You are asking the SQL to return an attribute value which is code. Do I have a code attribute? Yes, I do have a code attribute. Right, so I'm asking the SQL or the MS Access to return the value of code all these values that you see here from the shares table. All right, and then how do you run that? Go to design and you see this run symbol. Run that. Did I get the values? Yes, I got those values, right? I was saying that I only need the value for the column code. Now if you want more values, how about this? Let's change our query to get the firm name and price as well. So what should you do? Go to this one, and now you need to change the view to SQL view, and now here you should demand for other attributes also. You'll say select code, firm name, make sure that you are using the same attribute names, otherwise you'll get an error. Code, firm name and price, these are to be separated by comma. We go to design and then run. Okay, did this work? Yes, it did work. Alright, so what we have learned right now is how to write a SQL query. So I'll explain to you how the select query should be written, but I thought I should first show you how you have to do that in MS Access, although my slide has all that information. So let me read those information so that you feel confident. So extracting the information, use the SQL select statement to specify the subset of data you want to extract. You need to specify the ordering and grouping of the data. So group by, order by, this is something we will use in the next lecture, not today. Now the select statement specifies the result of the execution, not how it is to be done, right? So this is an interesting thing. I will add that to my discussion. So this is an interesting thing, that in select statement, the way I have written, I'm just asking for those values. I'm asking, select firm name, price, PE, quantity. I'm not saying how you have to select. I'm just giving you a direction that give me these attributes from table. That's it. So it specifies the result of the execution, not on how you get it, right? It has the option of using the other clause like where, group by, having, order by, and as, which we will be learning in next lectures. And this query that I had written ultimately got translated by DBMS. Okay, and that got translated into query execution plan. Now how do we write a query in MS Access? The way I did. So what was the step? In the Access, you can create a query using SQL view, and that's what I did. And for that thing to happen, you should already have a query written which Access will write, and then you have to modify that. That's what I did. So you can either create from SQL view, from an existing query, or you can use design view. We will do design view also, but not today, later. So what you should be doing, you start with a query wizard right here, and then when you do that, you select fields. It will eventually happen. So when you say query wizard, this is what you will see, and you should say simple query wizard. That's what I did. After that, you need to select some fields, right? I selected some fields, and then I hit run, and that's how I got that. Then you should change the SQL query. So if you want, well, maybe I should leave it on you to work out, and if you are struggling, please check with me in my office hours. Or should I try? I think I should give you another demo. So I already have shares query, right? This is something we had run. Let me create another query. Okay, so pay attention if you missed it in the first demo. Go to create query wizard. Okay, you must save the query. Do you want to save shares query? Yes, I want to save it. I'm creating another one. So here initially Wait a second, I think I messed it up altogether. I should go to shares here, the base table, and then I should say query wizard, and I'll say simple query, right? So after simple query, you need to create one query using the GUI. There's no other way, right? So in this GUI, I will click this arrow because it will take all the fields in and will generate a SQL query which will return all the attribute value for me. That's okay. Initially it has to do something. It will only let you modify that, right? I'll say next and I'll say finish. So this was my this is my previous query that I wrote, and I created another query. So these two queries are different. Look at the result. This result, something that I wrote, I was only interested in these three attributes, right? But the one that I just created, here I asked for all the values. So if you compare this result with the shares, you won't see any difference because I'm asking for everything that we have in the table. All the attributes that you have, give me all the values for all the attributes. Okay, so now let's modify this thing, right? Because that's what we need. Select this one, this should be highlighted, okay? Go to view and then SQL view. And this is how MS Access writes the SQL thing. But we will use our standard way. We will say select from name from shares. Alright, and we will run. Got it? Yes, we did write our query involving just one attribute. So let me explain to you why I'm writing these things, right? So I'll take you back to my lecture slides. Okay, cool. Okay, so yeah, this is what I needed. Alright, I need pen. And this pen color is red. I don't like red color that much. Use blue. Okay, good. So let me tell you a little bit about SQL. It stands for, you should know by now, SQL stands for structured query language. Okay, now structured query language is also called declarative. This is called declarative language, which means it is non-procedural. That means the same thing. Non-procedural. It's non-procedural language. It is a declarative language. We declare what we want. We do not specify how do we want that. So we will say something like this, we will say select. Select is the select keyword that we are learning, right? Select, we will say select. Then I will specify attribute names. This is a general select statement I'm writing, okay? I should have attribute names. Then I'll say from, and then should say table name. And usually we terminate that with a semicolon. So that's how we have to write a select statement. Select and then specify all those attributes that you want to be there in your result. And these attributes should be separated by a comma. And then you should specify from where do you want it. Alright, so for the very basic select statement, you need two information: the keyword select and from. So let me write this select that I used in the demo. I should say select and from. Do we know the table? Yes, we have just one table, shares. We want some information from shares. Alright, what do you need? Just to specify that here. So you'll say select code, a comma, form name, and then, oh sorry about that, this is creating an issue today. Eraser. And then we'll have price. Okay, yeah, so this will work. What we did, select, these are the three attributes. I should say select code, form name, and price from my shares. That's it, right? You'll get all the values for the these three attributes. Now it is possible, there's another way. Let me use this space. I want to come back to this slide because I might need to write a little bit more. Sometimes when you want everything, right, there is a shorter way to, oh sorry about that again. When you say select from shares, when you want all the attributes, then what we do, we don't list all the attributes, we rather write a star. So what will happen, it will return all the attributes that you have in your table with all the possible values. Alright, so now I have few more things in my slide. I'll cover that and then I'll come back and I'll explain to you. Okay, select star from from shares means you get, star means all, select everything. So what happened, you got all the data that you had in your table. Now there's this operation called projection. Projection means that I am not interested in all the attributes. I want some subset of attributes. So what are the subsets here? The share name and PE. Alright, so keep in mind that in the example that I have in the slide, the name is share name. But the demo that I am doing and the file that you have, we have the name of the attribute as form name. Okay, so if you're trying select share name and PE from shares, then it will not work. You have to change share name to form name. So you should use the proper name of the attribute. If you have that as fair name, you're using share names, you'll get an error. Alright, so this is project where you are interested in only having some attributes, not all. Then that is projection. And there's something called restriction. This is probably the last slide or the information that we have in today's presentation. Now suppose you don't want all the rows in the result. You only want to select some rows on the basis of an attribute. Okay, so this is called restriction. If you look at this whole data, then we can make some selection on the basis of an attribute. So what we only want those shares where the PE value is less than 12, right? So how should we do that? For that we will use a where clause. Alright, so let me add this where clause in my previous slide and explain to you how does it work. That's the reason I left this much space here. Okay, so this is restriction. So till now we were using select from. Okay, so let's say select code, form name, price and PE from shares. So what will happen? You'll get the value for 1, 2, 3, 4 attributes for shares. Now we want to move a step further. We want to apply restriction. I don't want all the rows. I only want the rows where PE is less than 10 I believe, or 16. I don't remember what it was. Wait a second, let me go and figure it out. less than 12. Alright, so when you're saying PE is less than 12, I want only those rows where PE is less than 12. So how do I put that? Here, for the condition thing, I will use a clause where. Okay, now this is my complete SQL statement where right here when I'm saying code, firm name and price PE, this is projection. Why projection? Because I want subset of the attributes that I have in my table. I only want 1, 2, 3, 4, 5 of these attributes. I don't want everything. I'm not using star. I know that this should come from the share, so I have from, and this I'm using where clause to use to impose restriction. Alright, so we have it. We wrote the one of the most basic SQL statement involving projection as well as restriction. So let's try this on the demo. It's a discard. Here we are. So form name, I think I had code, form name, price, and PE. Let's run this one. Okay, good. So it is working. Let's add one more thing that we just learned, and that thing is about restriction where PE is less than 12. Alright, so you can see now we are getting only those tuples or the rows where PE value is less than 12. Okay, good. I think we are done with the SQL part for today. Let me see. So what you have to do, just go over my lecture video, lecture slides and do a practice. So this is restriction. Select star from shares where PE is less than 12. So now we are using two clauses in select. In select statement, we are in fact using three clauses: select of select, from of select, and where of select. Alright, so select is a big statement in which we have a number of other clauses that we can use. So we are using select, that's one clause, from is another clause, and where is another clause. The purpose of from is to identify the source of the data. So from is followed by the table name, and select is followed by all the attributes that you want to have in the result. Where is followed by a condition that you want to impose on the tuples. Alright, so now you have this assignment, which is are we on the track, and it is based on your SBU awards data. So I'll say, please work on it. Alright, and the last slide, did we learn the objects that we had? Did we learn how to model a single entity? I'll say yes. Define a single database, we did with the shares. Learn some SQL operations, yes we did. Write queries on a single database table, yes we did, but that was very simple. Okay, and we will learn a lot in days to come. Alright, thank you so much. If you have any questions, please join me in my office hours or send me an email about it. Thank you so much. Have a good one. Bye bye.